next lectures, we're gonna take these object-oriented programming ideas and use them in a problem domain that is quite important for our programs to be able to communicate with the outside world. So if the program never prints anything, then or returns anything, or anyway changes the outside world, so then does it matter if the program is even doing, if it keeps everything to itself? So we have a situation, so either inside the Java program or in the communication of the Java program with the external world. We have a most general situation that then we're gonna refine later, that you have a bunch of bytes and you have them at the point A, and you want them to be at the point B also. So we call in this mechanism, we're gonna be looking at the Java stream libraries. Now this also, same as with the swing, so has actually been replaced with the Java new IO, non-blocking IO. My pet peeve, they're naming things new something, so that never conveys any information, and then as time goes by becomes misleading and obsolete. But so we're gonna be looking at this Java original streaming mechanism, because it also gonna be a good example of using decorators. So swing was a good example of a strategy objects, because most classes have so many methods that the decorator would be pretty painful. But then these streams have a nice small number of methods, and the decorator pattern then allows us to give these basic streams all kinds of interesting powers. But so the problem, you got some bytes at point A and you want them to be at point B. Like for example, point A would be some data structure that you have, and then B might be a file. Or then when we do the same mechanism with the text, so you got some text in your strings and you want them to appear on the standard output console. So how do we cross these kind of gaps? So then we have this model that consists of two symmetric classes, and then when we next do this for the Unicode characters, exactly the same with just the different class names. So we have this concept of a stream, that some kind of a pipeline connection that somehow virtually connects point A and point B. Now this stream is still entirely within the Java virtual machine, so this is similarly used, a similar feeling as with, let's say, the Unix pipelines, but that are for the operating system communication between processes and files. But then so this only like conceptually resembles the Unix pipeline, but this is all inside the Java, even if so point B is outside the Java virtual machine, but then inside the virtual machine we have some object that represents the thing that exists outside the virtual machine. So we have two abstract superclasses, input stream and output stream. The one you use, so depending on whether you are point A or point B. So suppose point B is a file, you want to write into a file. So from your end, it's an output stream. It is like an open end of a pipeline that you keep shoveling bytes. And when you shovel bytes into the pipeline, so you don't know and you don't care what exactly is at the other end of the pipeline, and what exactly is the transmission mechanism that takes your bytes and ensures that they will receive the destination, and whether there is some kind of transformations going on internally. So none of this affects your act of shoveling bytes into the pipeline. Now suppose you're reading bytes from a file. So now file is the point A and you are the point B, and then you are using some kind of input stream to read the bytes. So an output stream instance is communicating with some kind of input stream instance, or at least pretending that it does. Now let's look at the output stream first, because it's a simpler. Input stream is not as simple as it could have been. We can discuss that also. So when you are your face, this is the public interface of the open hole in the pipeline, waiting for your bytes in there. So the method reading through. So when you're done sending your bytes, so you can close the stream. So this somehow internally sends a special message and we don't know anything about how our bytes and blocks of bytes are encoded inside the stream. This tells the other end that there is no more bytes coming, that they can stop and go do something else, so they know that they're not waiting for data that you're never gonna be sending. So suppose you are writing bytes into a file, then you have to close to make the file available for other processes. So the operating system, the file system, ensures that only one process at the time can be writing to a file. So you gotta let go of the file, you gotta release the resource. That's what we're gonna be doing this in the finally block from last week. So that's what you say when you're done writing. Flush, we don't need today, we explained later what it was, but the write, the abstract version, writes a specified byte into the output stream, and then convenience method, suppose you have a byte array, and notice again the principle that because the entire array can be passed by the same reference, so it's convenient to make a method operating on an array to receive some additional index parameters telling look at only the sub-array defined by this and pretend that the rest of the array doesn't even exist. But now here looking at what kind of a data we are transmitting. So this is moving bytes around, and Java does have a byte, one byte in the primitive, so understandably this takes a byte array. But how come this method is taking an int? How come this one is not taking a byte? The reason is that there's two possible interpretations. So the byte is just 8 bits. It doesn't mean anything by itself. All the bytes and aggregation of bytes, they mean whatever you say they mean by the way that you handle them. If you take 4 bytes and treat them as an int value, then those 4 bytes are an int value. If you take 4 bytes with the exact same sequence of zeros and ones, and you treat them as something else, so then those bytes are something else. The bytes themselves have no meaning, they just are zeros and ones. But now, because there is 2 different ways to interpret the byte, the signed and unsigned. So now the signed byte can encode a negative value, so basically the range has been shifted, that is like a half on the negative side and half on the positive side, whereas an unsigned, the range of possible values is all on the non-negative side. And because the 0 is the odd man out in the middle, so then the signed bytes have one more value on the negative side. So a byte, the smallest value is minus 128, and then the largest value is plus 127, because there is an even number of different values, and then the 0 is the odd man out in the middle. But an unsigned byte has the values from 0 to 255, and this mechanism is supposed to transmit unsigned bytes, and therefore the write method, you give it the 4-byte int, but what it just says is that this uses the lowest byte, the 8 lowest bits, the lowest byte. The other bits are simply ignored. So at this one now we can represent the value from 0 to 255. So then of course this has a 2 billion more positive values, but we never use them, but it's just a whole bunch. So this 24 higher order bits are completely ignored. And the last one here in the output stream, so you can say, alright stream, stop buffering internally, I'm waiting for a response, so I cannot have you buffering a question that I sent forward. That question has to reach the recipient for sure. So this is the way to tell the stream, flush empty out all your inner buffers that you have. Make sure that everything that I've sent that can be delivered will be delivered. So that's the abstract mechanism. So write and close is the one we need. Flush we need only in two-way communication. We don't need it anywhere else.